All right, well, continuing Chapter 5 on human population growth and continuing our goal, which is to analyze how population size is determined by births, deaths, immigration, emigration, and limiting factors that determine carrying capacity. I think you've seen this far side before. Chicken wants to cross the road. It's the other side, obviously, and the sign says, "Why do you need a reason?" I've seen that somewhere before. I'm not sure where, though. Maybe you can remember. All right, moving on here. Our objectives are to discuss the trend of human population growth and also explain why population growth rates differ in countries throughout the world. I want to show you this video first. But before, think about how quickly is the global human population growing? And in the United States and other developing countries, the population growth rate is low, and in some developing countries, the population is growing very rapidly. Worldwide, there are more than 4 human births every second. What does the present and future human population growth mean for a species and its interactions with the rest of the biosphere? So watch the human time clock video. This is really fascinating. I know you're really, I know what I'm going to move to after this.
An environment is a system of living things. The Earth is our environment. The capacity of our environment to provide space, to produce food, and to supply energy are all limited. Humans thrive on less than 17% of the Earth's surface. Only about 4% will grow crops. We depend on these limited resources for our survival, and yet we're increasing our population as if they were infinite. This fact is at the core of our environmental problems. On this map, we'll show population growth from the year 1 AD to present, and then project our growth into the year 2030. Population concentrations will be indicated by dots, each of which will represent 1 million people. In areas where people are spread out and don't live in concentrations of 1 million, dots are placed in the middle of their approximate range. As some areas become superpopulated, dots will spread outward in order to show the total population within the map. Historical references will be provided by images and text on the lower right.
The history for you too. Here we go. Follow the dots. Go. Look at all the rapid decline there. Killed off a lot of people in China, the fungals. Black plague, watch this. Density dependent disease. Problem. People come back. Reproducing again. China, India, Europe. Here we go. New world. Oh my gosh. Population's coming over here soon. Europe, colonial America, not too much still. Look at China, India, Europe. Here we go, colonial America finally. Industrial age, bam. Even the world wars didn't have much of an impact on the population increase. Here we go. This is predictions into the future.
If present growth rates continue, our population will
I think
double
I'm going to move to Canada.
in years. If the Earth's size remains the same, slowing human population growth and lowering our consumption of natural resources is key to reducing the impact we have on our planet. Through our personal decisions about our numbers and our lifestyles,
All right, that's all I wanted to show you. I think it's really an interesting video, and I hope you enjoyed it too. All right, moving on back to our objectives now. Objective 1 is to be able to discuss the trend in human population growth, which you just saw quite a video of. So anyhow, for most of human existence, as you saw, the population grew very slowly because life was harsh. Food was hard to find, and predators and disease were common and very life-threatening. These limiting factors kept human death rates very high. Until fairly recently, only half the children in the world survived to adulthood. And because the death rates were so high, families had many children just to make sure that some would live. And as civilization advanced, life became easier and the human population began to grow more rapidly. That trend continued through the Industrial Revolution in the 1800s, and several factors, including improved nutrition, sanitation, medicine, and healthcare, dramatically reduced the death rates. Yet, the birth rates in most parts of the world remained high. The combination of the low death rates and those high birth rates led to this exponential growth, that J curve. This kind of exponential growth, cannot and will not continue forever. So 2 centuries ago, I like to call this guy doom and gloom too. English economist Thomas Malthus, that's his name, suggested that only war, famine, and disease could limit human population growth. Malthus thought that human populations would be regulated by competition, war, limiting resources, famine, and parasitism, disease, and other density-dependent factors. Malthus's work was vitally important to the thinking of that guy, Charles Darwin. Exponential growth continued up to the second half of the 20th century, reaching a peak around 1962, and then it began to drop. The size of the human population growth is still growing rapidly, but the rate of growth is slowing down. I'll show this video to you in class. So objective 1 is to be able to discuss the trend in population growth. The human population, like the population growth of other organisms, tend to increase. That rate of increase has changed dramatically over time. Objective 2. So why do human population growth rates differ among countries? All right, scientists have identified several social and economic factors that affect human population growth. Birth rates, death rates, and the age structure of the population help predict why some countries have high growth rates and while other countries grow more slowly. The scientific study of human population is called demography. Demography examines characteristics of human populations and attempts to explain how those populations will change over time. human societies had equally high death rates and birth rates, as you can see along here, for most of history. But over the past century, the population and the growth of the United States, Japan, and much of Europe has slowed dramatically. To explain this shift, demographers hypothesize that these countries have completed the demographic transition, a dramatic change from high birth rates and death rates to low birth rates and death rates. The demographic transition is associated with an increase in the quality of health care and improved access to education, especially for women. Think about why that would be important. So, most of the current global population growth is concentrated in developing countries. The demographic transition is divided into 3 stages. Stage 1, birth rates and death rates are high for most of history, as you can see here. The red line and blue line are birth rates and death rates. They're high, all right, over time here. Stage 2, due to advances in nutrition, sanitation, and medicine, led to lower death rates. Birth rates, though, because of cultural reasons, remained high for a time. So birth rates greatly exceeded deaths, and the populations increased exponentially. During stage 3, as the level of education and living standards rise, families have fewer children and the birth rate falls. Population growth then slows. The demographic transition is complete when the birth rate meets the death rate and the population growth stops. So far, the United States, Japan, and Europe have completed the demographic transition. Parts of South America, Africa, and Asia are passing through stage 2. A large part of ongoing human population growth is happening only in 10 countries, with India and China in the lead. So globally, human population is still growing rapidly, but the rate of growth is slowing down. Our J-shaped growth curve may be changing into a logistic curve. So to understand population growth in different countries, we turn to age structure diagrams. These are what we call age structure diagrams. These diagrams compare the age structure of the U.S. population and with that of Guatemala. These are the ages along here, and this is the population, and then you have divided, of course, into males and females. In the United States, there are nearly equal numbers of people in each age group for quite a while. This age structure predicts a slow but steady growth rate for the near future. So not one age is overcoming another, and because these people here, this area, are reproducing at the same rate consistently, so it's just a slow, steady growth rate. Okay? In Guatemala, though, on the other hand, there are many more young children than teenagers, and many more teenagers than adults, as you can see from this pyramid-like structure. This age structure predicts a population that will double, it will continue like this, in about 30 years. So what does this difference in age structure imply about future growth of each population? Think about that. So to predict how the world's human population will grow, demographers consider many factors, including the age structure of each country and the effects of diseases on death rates, especially like AIDS in Africa and parts of Asia. Current projections suggest that by 2050, the world population will reach, let me see something real quick. Yes, about 9 billion people. The human population may level out to a logistic growth curve and become stable if countries that are currently growing rapidly complete the demographic transition. Current data suggests that human population growth will grow more slowly over the next, this is the growth rate, percent increase, over the next 50 years than it grew over the last 50 years, because the growth rate will still be higher than 0 in 2050, our population will continue to grow. So what is the carrying capacity of the Earth? The carrying capacity of Earth for humans is very uncertain. With technology advances, maybe we'll figure out ways to have better resources for food, grow food faster and better, which people are actually working on. Scientists are doing that. So the average estimate is right now between 10 to 15 billion. Currently, we're just over 7 billion people for how many people on Earth. Objective 2 was to be able to explain why population growth rates differ in countries throughout the world. Birth rates, death rates, and the age structure of the population help predict why some countries have high growth rates while other countries grow more slowly. So please ask yourself, can you discuss the trend in population growth? And can you explain why population growth rates differ in countries throughout the world? And I think that's it for Chapter 5. We'll move on to Chapter 6 coming up.